Good morning, students. So today I'm going to explain you on chapter 3, that is the reactivity of metals. Reactivity of metals. I have already shared you the notes. Hope you have already copied it in your notebook. So please use this video for understanding of the notes that you have already copied in the notebook. Uh, let's see what things we are going to learn in this chapter. Firstly, we'll talk about metals. Then we will talk about non-metals, and we will also briefly talk about third type of elements, metalloids. So what are the details, what are the things we are going to learn in this? We'll learn the definition of metals, examples of metals, and why we call them as metals, and elements of which groups in periodic tables are called metals. Then we will see, similarly we will discuss the non-metals, definition of non-metals, and some examples, and metalloids also, definition and some examples. After that, we are going to see the physical and chemical properties of metals and non-metals, and with this the first part of the chapter will come to the end. All right, let me start with metals. So metals, in lower classes we usually define metals as those substances which will do conduction, which are hard, which are not breakable, and so on. But now the definition of metal is little bit changed, because our standard is also changed. So metals, we define metals as elements which lose electrons. So it means elements which lose electrons. It means that metals will lose electrons from their valence shell. And let's see how it is happening. Suppose I have metal M. So metal M, from here I am taking one electron out, so minus 1e. That means from metal atom M I am removing one electron. So metal atom M will convert into M plus, because it has lost one electron and it will develop one positive charge. So this is neutral atom. This is a cation, because this is positively charged ion. This is a neutral atom M. Alright. So now we can say that metals are those elements which lose one or more electrons from their valence shell and convert themselves into positive ions called cations. Other examples: sodium will lose one electron and sodium will convert into Na plus. Why it is doing like that is because we have to go back to the electronic configuration. Suppose sodium electronic configuration is, atomic number is 11. So electronic configuration is 2, 8, 1. By looking at the electronic configuration, we can know that sodium can lose this electron, one electron from its valence shell. Now one electron is lost means what is the configuration remaining is here for Na plus 2, 8. See, this is stable. It has octet configuration. This was not stable because it was having one electron in the valence shell. One more example: magnesium will lose two electrons. Now I will write other side plus 2 electrons, and how magnesium will change is Mg2 plus. So this is how magnesium is going to change. This equation and this equation is same. This is for sodium, minus this side we are doing, but here giving it, that means this side we will write plus. Actually the way we write is different, but the meaning is same. Another example, let's do for aluminum. Basically, so 2, 8 and 3 is the configuration. So aluminum will lose these 3 electrons, minus 3e, and aluminum will convert into Al3 plus. This is aluminum cation, this is magnesium cation, this is sodium cation. So all these cations, 1, 2, 3, they are positively charged. Before we move to non-metals, let's see examples of elements in group in the periodic table. Basically, group 1 and group 2 elements in periodic table, we call them as metals. Group 1 are called alkali metals. Likewise, group 2 elements are called alkaline earth metals. Alkaline earth metals. Group 1 alkali metals, group 2 alkaline earth metals. So please remember this and some examples also. Now let's go to non-metals. Non-metals. Now we will have the opposite definition of metals. Elements which lose electrons are metals. Now non-metals, elements which will accept one or more electrons. That means they will have vacancy for electrons. When they accept electrons, and they will convert into negative ions called anions. Let's see example. Directly we'll see the example. We'll do it for chlorine. Chlorine, let's see the configuration. 2, 8, 7. Now by looking at the configuration, we can see that chlorine is having 7 electrons in the valence shell. 7 electrons. So it needs 1 electron for becoming stable. So let's add 1 electron. Chlorine getting 1 electron. So when chlorine accepts 1 electron, it will convert into negative ion. This is our chloride ion. If you see the configuration, it will be 2, 8, 8. This is how it is happening. So this is an anion. These positive ones are cations. Now this is anion, A-N-I-O-N, anion. Let's see another example. Chlorine. Let's do for oxygen. 2, 6 is the configuration. So 2 electrons it has vacancy plus 2e. Then oxygen will convert into O2 minus. So likewise we can write for other non-metals as well. Next one, metalloids. These are the elements which usually have the properties of both metals and non-metals. They will behave as metals and non-metals based on the situation. They have the properties. Sometimes they will lose electrons, sometimes they will gain electrons. Examples, boron, silicon, arsenic, etc. So if you see it in the periodic table, those green colored elements, they are the metalloids. 1, 2, 3, 4, 5, 6, 7. We have 7 metalloids here. Is it okay? Definition: behave both as metals and non-metals. Behave both as metals and non-metals. So in this particular video, I explained you about metals, non-metals and metalloids, some reactions, how they form cation, positive ions cations and negative ions anions, and examples we have seen, and also we have seen the definition of metalloids and some examples of metalloids. Next part of the video, let me quickly talk to you about the physical and chemical properties of metals. If you see it in the textbook, page 44 and 45, you will find all the details. Physical properties. physical properties of metals and non-metals together. Number one, state. Metals are solid. All metals are generally solid, except we have some exception is there. We have mercury, which is a non-metal. Likewise, all non-metals are they exist in three states of matter. There is one non-metal, that is bromine, which is the liquid, which is the only liquid. Likewise, density density metals usually have very high density, and non-metals low density, but diamond will be having very high density. Melting point, metals have very high and non-metals very low. Boiling point, high, low. Hardness, hard, except mercury, sodium, calcium. Okay, these are soft. And non-metals, they are generally soft except diamond, which is very hard. Malleability. Malleability is a property in which a metal can be beaten into thin sheets. We can make thin sheets out of metal. That means all metals are malleable except zinc and mercury. Non-metals, non-malleable. That means they are generally brittle, they can break. Likewise, ductility, we can make them into thin wires. Metals can be converted like that except sodium, potassium. Non-metals, they are non-ductile and cannot be drawn into thin wires. Good conductors of heat, poor conductors of heat. Electricity also same thing. Metals are good, non-metals are bad conductors except graphite and gas carbon. So this exception we need to remember. Then let's see, luster means whether they will shine or not. Newly cut metals have high luster. Non-metals usually they are non-lusters except iodine is having the luster. Iodine has the luster. Alloy formation, whether we can mix them with other metals and make a third type of metal. So usually metals form alloys. Non-metals do not form alloys. And tenacity, this is one physical property which have tensile strength. Talks about tensile strength. Metals usually have high tensile strength, and non-metals they have low tensile strength. That's all about the physical properties of metals and non-metals. Now let me quickly talk about the chemical properties, and here few points are very important. Chemical properties. Chemical properties of metals and non-metals. First one is electronic configuration. So usually metals will be having 1, 2 or 3 electrons in the valence shell. That is why they will lose the electrons. Likewise, non-metals, they usually will have 5, 6, 7 electrons. So they will gain the electrons. So this is the electronic configuration. These are metal. This is non-metal. Metals will have 1, 2, 3 as valence electrons. So they will lose. Non-metals 5, 6, 7 electrons in the valence shell, so they will gain electrons, so that in both the cases there will be octet or duplet configuration. Ionization and change of ion. Next is ionization. So metals, they will lose electrons, and non-metals, they will gain electrons. When they lose electrons, metal will be forming positive charge ions, and non-metals will be forming negatively charged ions. Example, sodium loses 1 electron, so sodium will become Na plus. This is in case of metals. Likewise, we have non-metals. Let's see, oxygen gains 2 electron and converts into O2 minus. So here what we can see, how they ionize. Metals will ionize by losing electrons, non-metals will ionize by gaining electrons. Deposition during electrolysis. So metals will be deposited at the cathode. Metals at the cathode, non-metals at anode. So more about this we will learn in class 10. Now it's not required. 4. Valency. Metals, they will have electrovalency because they will lose electrons, or they will usually form electrovalent bonds. And non-metals, they will have covalency. Metals, electrovalency. and non-metals covalency and electrovalency, both. It will have both. That's all. We have other chemical properties also, such as redox agents, then nature of oxides, atomicity, then action, that means reaction with chlorine and dilute acids. One, two, three, four or five chemical properties still remaining. These chemical properties we are going to cover up as we discuss the reactivity series. We'll see the details because these things will be there in the reactions, and these things will be covered up in this topic, reactivity series. So in the next video I'm going to post the details. I'm going to discuss about details about the reactivity series. So with this we come to the end of this video. Thank you.